we are covering geometry section 10.3, which is formulas in 3D. Take your notes and do the check it out problems. This one actually has some check it out problems, the last one didn't. So just be ready.
Oh, so we have two learning targets today. I can apply Euler's formula to find the number of vertices, edges, and faces of a polyhedron. And I can develop and apply the distance and midpoint formulas in 3 dimensions. Should be fun to do.
Oh yeah.
Oh yeah.
All right, so a polyhedron is formed by 4 or more polygons that intersect only at their edges. Prisms and pyramids are polyhedrons, but cylinders are not. And here's examples. All of these have nice edges, meaning they're polyhedron. No edges, no polyhedron. How's that for good English? So what's Euler's formula? Euler's formula is a way, I think it's really brilliant, yeah, to verify that something is a polyhedron. And it's something very clever that he figured out. So it says for any polyhedron with V vertices, E edges, and F faces, the following is true. The number of vertices minus the number of edges plus the number of faces is equal to 2. And it's very clever. You could have a 1,000-sided polyhedron, and it is going to, this formula will work. So I don't know how many sides he looked at, but
Holds true.
I think it's very clever.
So we want to find the number of vertices, edges, and faces of the polyhedron, and then use the results to verify Euler's formula.
This actually is not correct.
Oh, so ignore those.
Ignore those. Those go with the next problem.
Okay, so for vertices, again, we're going to be number of vertices. We're counting the number of points. We have a 6-sided figure. 1, 2, 3. Yep. So we have a hexagonal prism. So we're going to have 6 and 6. We're going to have 12 vertices. Number of edges. We're looking for the lines. So we're going to have 6, 6, and then 6 going around, which would be 18. And then our faces. We're going to have 6, 7, 8 faces. So now Euler's formula tells us that, to verify that, see if we counted correctly, we're going to get 12 minus 18 plus 8, does that equal 2? We're just going to get 20 minus 18 equals 2, or 2 equals 2. And yes, that works. Yay, we got it right. So cool.
Okay, this is the next
Oh,
one.
see, yes, and we already have everything here for you. So the vertices, again, we've got 1, 2, 3, 4, 5. Edges, we have 1, 2, 3, 4, 5, 6, 7, 8 edges. Nice. And then our faces, we've got a mess going on there. It's a 4-sided pyramid, so it's a rectangular pyramid. So we've got 5 faces. I can't draw anymore on there, it'd be messy. So Euler's formula checks here. We have vertices minus number of edges plus the faces. Does that equal 2? And yes, it does. So we're good there.
So here's your check it out. You need to verify Euler's formula by finding the vertices, edges, and faces of that one.
Nice.
So a diagonal in a 3D figure, it's like it goes from this upper corner here, so this is the upper left corner, down to the lower right corner. So it's not straight.
Consecutive.
It's actually, it is a diagonal, which is what they call it, but it's a diagonal in 3D. So it not only goes downward, but it also goes across to the other side of the figure. So the length of a diagonal, it is kind of like the hypotenuse on a right triangle, so it looks a lot like Pythagorean theorem. Length of diagonal of a right rectangular prism with length L, width W, and height H is, the diagonal is equal to the square root of L squared plus W squared plus H squared. So we're going to look at a few examples. Find the unknown dimension of the figure, the length of the diagonal. We want to find the length of the diagonal, and we see that it is 6 by 8 by 10. So we're going to plug these into this formula that we have. And remember, you want to square before you add. So you're going to get 36 plus 64 plus 100, which is the square root of 200, gives you about 14.1 centimeters. The next one, we want to find the height. So we're given the diagonal is 15 inches and we know that we have length and width of 12 and 7. So again, write the formula down that you're using. I always recommend that. Diagonals equal to the square root of L squared plus W squared plus H squared. So this would go here, this would go here, and then this one would go here, and we're left with, it looks kind of like a football play, doesn't it? Anyway, we're left with H. Again, the first thing you want to do is, well, you could do it a number of ways, but the first thing they do is get rid of the square root by squaring both sides. That undoes the square root, and then they square the 12 and the 7 to get this. If you add those up and subtract from 225, you get h squared is 32. And we solve for square, when something's square, we have to square root it to solve. So we're going to get the square root of 32, which is 5.7 inches.
Nice. So now, we're doing this one too.
This is a check it out.
Oh, here's your check it out. Find the length of the diagonal of a cube with edge length 5 centimeters. So remember, it's cube, all sides are the same length. So keep that in mind. Oh, and space. Now we're moving into coordinate plane. So space is a set of all points in 3 dimensions. In 3 dimensions, we have, in the coordinate system, we're going to have, do you notice, we now have the x coordinate here. Or z coordinate. X is coming at you, y comes a horizontal one, and c is our vertical axis in 3D. So it looks a little bit different, but it's hard to draw a 3D and a 2D thing. So think of it, the graph is sloping down, or it's kind of skewed, so you can see all 3 of the axes. When you're asked to graph these now, you can start here. So we want to graph the point 3, 2, 4. It goes x, y, z. So we can start at the origin. We go down 3 positions on our x-axis. Then we're going to go over 2, which is going to be a horizontal move for y. So you're looking kind of the tick marks and eyeballing it because the graphing is never accurate. Then we have to go up 4. So it's 1, 2, 3, 4. Again, you're kind of looking the tick marks on the z-axis, and I'll put it up there for your point. So if you have 3D graph paper, it's going to make it a lot simpler to graph.
It sure does,
Yeah.
because Miss Aiken, I'm going to let you do this because I'm terrible at this.
Yeah. So, some of us are spatially challenged. I
am.
I'm with you on this too. So we want to graph a rectangular prism with length of 5 units, width of 3 units, and a height of 4 units. The nice thing is one of the vertices is at the origin 0, 0, 0. So again, we can start at the origin, and we're going to do length of 5 units, which so on the x-axis we go out 5 units. And then we can do the width of 3 units. So we're going to kind of do different things here. Go out 3 units from this point. So this is one vertex. This will be another vertex. And then it has a height of 4 units. So from here, we can go up 4. And you start to see that from this one, we can also go up 4. So we've drawn in one face. From here, from each of these vertices now, we need to take this point back 5 and put you back up on the y-axis where we started. And then this one's got to go back 5. This side goes back 5. Our height has to go up 4 from each of the points we just drew in. And we need this one coming down from that point there. And then we have 3, and we just learned from this point, just connect the dots we haven't connected yet. We got it. So initially what you're going to be drawing is the front face. When you plot your point, you're going to get that piece from what we're looking at, which is the face looking at you. Does that help you at all?
Very nice, thank you. I'm better at this one. Graph a cone with a radius of 3 units and a height of 5 units. And again, it's centered here, which is nice. So the radius is going to go out 3 units in all directions. So here's our origin. Go out 3, out 3, out 3.
You have to go back 3.
And back 3, right. And then you can kind of connect your circular base. And then from here we want to have a height of 5. And then we just are going to basically connect our height to our 2 sides. So that one's a little easier. And hopefully you can kind of visualize where those points would be. They're going to be 3 units out in this direction, and 5 units up here.
It's a treat. You'll enjoy this.
Oh, yeah. So, you should graph a cone with a radius of 5 units, height of 7 units, center at 0, 0, 0.
So when you're check it outs. Okay, so now we're going to move into distance and midpoint formulas in 3D. And the nice thing is, we're just adding on. So we have 3 coordinates, x, y, and z. So we have 2 points, x1, y1, z1, x2, y2, z2. This piece here was what we used in 2D to find the distance. So now we have our z coordinate to add in, the difference of our z coordinates. So that's really just an add-on. Midpoint, same thing. The first part of our midpoint formula, taking the average of our x coordinates and the average of our y coordinates, what we've done in our 2D. Moving to 3D, we have to consider our z coordinates now. So we're just adding on.
Should be pretty straightforward.
Should be.
Famous last words. Anyway,
Let's
find the
see.
distance between the given points, find the midpoint of the segment. So be careful on these questions. You're asked for 2 things, midpoint and distance. So here is, I always recommend, whoops, where'd it go? I always recommend labeling x1, y1, z1. Can you read that? No.
Yes, it's fine. It's wonderful.
It's an awful Z, sorry. Z1. And then we've got, whoops, it didn't change. X2, Y2, Z2. It just helps you plug things in the formula a little bit better. Here's our formula. We're going to plug our x1, y1, z1, and x2, y2, z2 into the right places. Just be careful. You're going to get negative 2 squared plus negative 5 squared plus 9 squared. Please put this,
Keep it in parentheses and you square it.
please put this in your calculator like this, else you will get the wrong answer. And so if you end up with a negative under square root, you've done something wrong. All right, so you're going to end up with positive 4, positive 25, and positive 81. The square root of 110, or 10.5 units, is going to be our distance. And then midpoint, again, here's our formula. Plug things in the right places, add them, and you're going to end up with midpoints of 5, 8.5, and 7.5.
Again, midpoint we're adding is the average. Where distance, we're sort of taking the difference of the x coordinates, y coordinates, and z coordinates and squaring them.
So be careful.
So now it's your turn to do the check it out. Find the distance between the given points and the midpoint of the segment with the given endpoints. Your points are 0, 5, 0, 9, 5, and 6, 0, 12. Good luck.
All right, and we are done. So summary, Euler's formula allows you to check a polyhedron to see if something is a polyhedron. You use it by finding a number of vertices, edges, and faces and plugging it into that formula. Diagonal of a right rectangular prism, like the Pythagorean theorem, with 1 extra parameter. And then lastly, our distance and midpoint. Again, we're just adding one more thing to the distance and midpoints we already have.
Always adding on something.
That's right, it always gets more complicated. So bring your questions to class.
Thanks. Good luck.